Welcome back to my garage. Again, I'm Mr. Rice, and we've been working on building circuits for physics and chemistry. And I wanted to do the analysis now of the series resistor and LED circuit. So I want to do the actual circuit analysis. Come up to the board. Here's Charlie again. He's working really hard today, helping us out. Okay, so here's the schematic that we had of the two resistors in series with the LED. So because the LED is a relatively constant voltage device, we can use that in our analysis. One of the first things the lab asks you to do is find the current flow through this circuit, through the LED. And because it's a series circuit, whatever current flows through the resistors also flows through the diode. The same current flows through each and every component of the series circuit. The easiest way to do this is because of this constant voltage device, what we can do is we can mathematically take the 2 volts away and say that only 7 volts is applied across the 2 resistors, and we can solve the current that way. It's much easier solving the current through basic resistors with Ohm's law than it is to use a logarithmic function to solve the current through a diode. So for our purposes for the analysis, I'm going to temporarily take the diode away. Remember, that was a constant 2-volt drop. And I'm going to say across the 2 resistors, R1 and R2, connect those together, we have a 7-volt supply. R1 was 330 ohms, R2 was 330 ohms, like so. 7-volt supply. So we use Ohm's law to calculate the current flow. Conventional current flows this way, like so. I for amperes. And electron flow flows from negative to positive the other direction. So we're going to start with using the equivalent resistance or total resistance formula. So RT of the circuit is R1 plus R2. The resistors are in series, so you add them up. If they were connected together in parallel, the way household appliances are connected, it would be a different formula. R1 plus R2, 660 ohms. Like so, 660 ohms, that's the total resistance. So now we're going to go ahead and use Ohm's law. I'm going to erase this part of it. So RT, 660 ohms. Our voltage applied, battery, 7 volts. Ohm's law says that voltage is equal to current times resistance. We're asking to find the total current of the circuit, the series current. I series, or I total, is equal to voltage applied divided by RT. Just a manipulation of Ohm's law. Total current would be 7 volts divided by 660 ohms. And that's going to be just about 10 milliamps, I think it's 0.0106, something like that. So about 10 milliamps of current.